Hello everyone. In this tutorial, I discuss about 8085 pin description of microprocessor. So there are 40 pins in 8085 microprocessor. These are 1, 2, 3, 4, 5 and end it 40. Okay. So in the following microprocessor, you see that here A8 to A15. That's are called address bus. Okay. So what are actually address bus? Address bus, the most significant 8 bits of the memory address or the 8 bit of the input output address. So 3 state during hold and halt modes, and that's a mainly output state. Okay. And next you see that AD0 to AD7, that's are called address data bus, and lower 8 bits of the memory address or input output address appears on the bus during the first clock cycle. Okay, appears on the bus during the first clock cycle of address data bus. Then it becomes the data bus during the second and third clock cycle, and 3 state during hold and halt modes. Next you see here SO এবং S1. Here S0 and S1. Next, what are these? These are called data bus state, encode status of the bus cycle. So S0 and S1 like that. When that's are S0, that's are S1. When both are 0, then that the process halt. And next S0 0 এবং S1 1, then the process read. Okay, and next 1 0, then the process is write, and next one 1 1 is fetch. Okay, now here you see the read RD, that's the clearly RD. Okay, so RD is output state, and that means read indicates the select memory or input output device is to be read and that the data bus is available for the data transfer. Next you see that write, WR or write. In this indicates the data on the data bus is to be written into the select memory or input output locations. Data is set up at the trailing edge of write, 3 state during the hold and halt modes. Then here you see the ready. So ready, if ready is high during a read or write cycle, it indicates that the memory or peripheral is ready to send or receive data. And if ready is low, the CPU will wait for ready to go high before completing the read or write cycle. And next one is hold. Here you see that the hold. Okay, so actually what are the words of hold? Hold indicates that another master is requesting the use of another address and data buses. The CPU, upon receiving the hold request, with the use of bus as soon as the computation of current machine cycle. Okay, now I discuss about HLDA. Okay, so actually what is that? The acknowledgement indicates that the CPU has received the hold request, received the hold request, and that will be the replenish the buses in the next clock cycle. Next you see that enter, that's a enter. So that means interrupt request is used as a general purpose of interrupt. It is simple or sampled only during the next to the last clock cycle of the instructions. If it is active, the program counter or PC, we know that program counter or PC will be invalid from incrementing and INTA will be issued. Then INTA, what are that? It's mainly output state. The interrupt acknowledgement is used instead of read during the instruction cycle after an accepted. It can be used to active the 82859 interrupt C. So next one is, here you see RST 7.5, RST 6.5, RST 5.5. So what are that? The here restart interrupt, this is 3 input have the same things as INTA or inter, except that they cause an internal register to be automatically inserted. So RST 7.5 is high priority and RST 5.5 is low priority. So next one is trap, TRAP. It's mainly input state, and the trap interrupt is a non-maskable restart interrupt. It is recognized at the same time as inter. It is unaffected by any marks or interrupt enable. So restart in. Next one is reset in. Okay. So reset set the program counter to 0 and reset the interrupt enable and held flip-flops. None of the other flags of register are affected by CPU is held in the reset conditions as long as reset is applied. Now next one is reset out. That's are the reset out in this pin number 3. So indicate CPU is being reset, can be used as system reset. The signal is synchronized to be processor clock. Next, pin 1 and pin 2, X1 and X2. What are that? Crystal or RC network connections to set the internal clock generator X1 can also be an external clock output instead of the crystal. The input frequency is divided by 2 to give the internal operating frequency. So clock out. Next is clock out. That's the 37 number pin. So in clock out, for use as a system clock when a crystal or RC network is used as an input to the CPU. The period of CLK or clock is 2 is the X1 and X2 input period. So next one is input modes output. Input memory output. Okay, that's whether the read and write to the memory or input output transmitted during the hold and halt modes. Next is SID. So that's our SID pin number 5. So SID serial input data line. The data on the line is loaded into the accumulator bit 7 whenever the RIM instruction is executed. Next is SOD. Here the SOD, serial input data. SOD means serial output data and SID means serial input data. Okay, so serial output data line, the output SOD is set or reset as specified by the SIM instruction. So next is VCC. VCC means plus 5 volt supply, here the power supply, and VSS means that's the 20 number pins, means ground reference. So that's are the pin description of 8085 microprocessor. So thank you everyone and subscribe my channel. See you in next one.